ఇంపార్టెంట్ టాపిక్ ట్రిపుల్ ప్రోడక్ట్స్ అండ్ మల్టిపుల్ ప్రోడక్ట్స్. ఈ ట్రిపుల్ ప్రోడక్ట్ అంటే ఏంటి, దాన్ని ఏ విధంగా విభజించాము, దానికి సంబంధించిన సూత్రాలు, వాటి వివరాల గురించి మాట్లాడుకుందాం. ట్రిపుల్ ప్రోడక్ట్స్. ఫస్ట్, ట్రిపుల్ ప్రోడక్ట్స్ ఆర్ క్లాసిఫైడ్ ఇంటూ టూ టైప్స్ మా. దే ఆర్ స్కేలార్ ట్రిపుల్ ప్రోడక్ట్స్ and second will be vector triple products. Multiple triple product of the vectors will be scalar triple products and vector triple products. Actually, how to apply between three vectors two products ma? For example, you consider let a bar, b bar, c bar, any three vectors. First I wanted to apply a bar dot b bar and dot c bar. And between these three vectors applying two dots. As this type of triple product possible or not, first we will go through it. The dot product of two vectors is a scalar and it is a vector. Between scalar and a vector, dot is meaningless. This type of triple products will be not allowed. And second, I wanted to put a bar dot b bar cross c bar, and applying dot and cross between a bar and b bar here. What is the value of a bar dot b bar? A bar dot b bar will be is a scalar and c bar is a vector. Between scalar and a vector cross, this is also meaningless. Earlier classes we have discussed dot product is between two vectors only, cross product is between two vectors. But here scalar and a vector dot, this type of triple products is meaningless. And to calculate the triple product of the vector, how we have to take the products? So here first I wanted to put a bar cross b bar and cross c bar. Cross product of two vectors is a vector and is a vector. Between two vectors cross product, it is meaningful. And a bar dot b bar cross c bar. Cross product of b cross c will be a vector and here a vector. Between two vectors dot, this type of triple product will be meaningful. But earlier what we have noticed, that type of triple products will be meaningless. Consider and another format, a bar cross b bar cross a bar, and here it will be a vector quantity, here it will be vector. Between two vectors vector, this is also meaningful product. And here next will be a bar cross b bar dot c bar. So the cross product of a bar b bar will be a vector and a vector between two vectors dot. And here though we wrote 4-5 examples, here we noticed that this cross product and this will be applicable, the rest of the two is ignored. We will classify triple products into scalar and the vector. What is scalar triple product? What is vector triple product? First we define scalar triple product. How to apply dot and cross between the three vectors in the previous example we have noticed. Now scalar triple product. The definition of the scalar triple product. A bar, b bar, c bar, any three vectors. A bar cross b bar dot c bar or a bar dot b bar cross c bar. These two products are called, they are called scalar triple products. If a bar, b bar, c bar three vectors, then a cross b dot c or a dot b cross c, these two products we call as the scalar triple product of the three vectors. Just now this is a vector between two vectors dot between two vectors, it is meaningful. And vector triple product, a bar, b bar, c bar, three vectors. Then the product a bar cross b bar cross c bar and a bar cross b bar cross c bar, these two products we call as the vector triple product. The first two products will be the scalar triple product and the next two products will be the vector triple product. Now first scalar triple product, vector triple product definitions we have seen, their properties, and together we will discuss about the in detail. In the properties of the scalar triple product, first we have seen that A bar dot B bar cross C bar or A bar cross B bar dot C bar known as box of A bar B bar C bar. In the sense, A bar dot B bar cross C bar will be is equal to A bar cross B bar dot C bar, both of them will be is equal to box ABC. And in the scalar triple product, we noticed that dot and cross can be interchanged. And second, scalar triple product is a scalar quantity. If box of ABC is positive, then A bar, B bar, C bar forms right-handed system. Earlier we have discussed what is right-handed system, what is left-handed system. If box of A bar, B bar, C bar less than 0, then A bar, B bar, C bar forms left-handed system. And if box of A bar, B bar, C bar is equal to 0, then A bar, B bar, C bar are coplanar. Why they are coplanar? How we define? Box of A bar, B bar, C bar is equal to A bar cross B bar dot C bar is equal to 0. A cross B will be perpendicular to C bar. But we know that A cross B is a vector which is perpendicular to the plane A bar B bar, and if you call this will be some N bar, then N bar dot C bar will be parallel. So when the vectors are lies in the same plane or parallel plane, then we call coplanar. So box ABC equal to 0, then the three vectors will be coplanar. Or if A bar, B bar, C bar are coplanar, then box of ABC will be is equal to 0. Box of I bar, J bar, K bar will be is equal to I bar dot J bar cross K bar, and that is nothing but I bar dot I bar, which is equal to 1. Box of IJK is equal to 1. And next, box of A bar, B bar and B bar. If a vector is repeated, the box value will be 0. And next will be box of A bar, B bar, C bar is equal to minus box of B bar, A bar, C bar. And when one vector is rotated in the box, multiply with minus 1. And another rotation if you did, that is B bar, C bar, A bar. If a box is first or second, third is combination of 2, 3 vectors, that is A bar plus or minus B bar, C bar, D bar can be written as box of A bar, C bar, D bar plus or minus box of B bar, C bar, D bar. If a vector is repeated, the box value will be 0. When one vector is rotated in the box, multiply with minus 1. If vector is addition or subtraction of two vectors, that box can be split into two boxes. Vectors are given in the linear combination, that is if L bar is equal to L1 times of A bar, L2 times of B bar, L3 times of C bar, M bar is equal to M1 times of A bar, M2 times of B bar, M3 times of C bar, and N bar is equal to N1 times of A bar, N2 times of B bar, N3 times of C bar. And the vectors are given in the linear combination, then box of L bar, M bar, N bar is equal to determinant of the 3 by 3 matrix L1, L2, L3, M1, M2, M3, N1, N2, N3 into box ABC. And moreover, if A bar, B bar, C bar direction ratios are given, if A bar is equal to A1 times of I bar, A2 times of J bar, A3 times of K bar, B bar is equal to B1 times of I bar, B2 times of J bar, B3 times of K bar, C bar is equal to C1 times of I bar, C2 times of J bar, C3 times of K bar, then the value of box of A bar, B bar, C bar is equal to determinant of A1, A2, A3, B1, B2, B3, C1, C2 and C3. Properties of the scalar triple products. క్రాస్ ప్రోడక్ట్కి సంబంధించినటువంటి అప్లికేషన్లు ఏరియా ఆఫ్ ది ట్రయాంగిల్, ఏరియా ఆఫ్ ది క్వాడ్రిలేటరల్, ఏరియా ఆఫ్ ది ప్యారలలోగ్రామ్, ఏరియా ఆఫ్ ది రెక్టాంగిల్. ట్రిపుల్ ప్రోడక్ట్ సంబంధించినటువంటి అప్లికేషన్లు వాల్యూమ్ ఆఫ్ ది జామెట్రికల్ ఫిగర్. అంటే టు ఫైండ్ ద వాల్యూమ్ ఆఫ్ ది గివెన్ సమ్ జామెట్రికల్ ఫిగర్స్ వి అప్లై ద ట్రిపుల్ ప్రోడక్ట్స్. ఏ బార్, బి బార్, సి బార్ ఎడ్జెస్ ఆఫ్ ఏ ప్యారలలోపైపుడ్, coterminous edges of parallelopiped. Then its volume. Consider a parallelopiped with A bar, B bar, C bar as the adjacent sides. Cubical shape of the parallelogram. Okay, this is A bar, B bar, C bar are the edges of a parallelopiped. Its base area into height, volume of the figure. So volume of the parallelopiped will be V is equal to modulus of box of A bar, B bar, C bar cubic units. Base area into height, A cross B dot C. And this parallelopiped ఇప్పుడు 1/6 part if you cut, then it becomes a tetrahedron. Volume of the tetrahedron is V is equal to 1/6 of the volume of the parallelopiped, 1/6 times mod of A bar, B bar, C bar cubic units. If A bar, B bar, C bar are the edges of the tetrahedron, volume of the tetrahedron is 1/6 times of box of ABC. A bar, B bar, C bar are the edges of the parallelopiped, volume of the parallelopiped will be box ABC. If A, B, C are the A, B, C, D are the vertices of a parallelopiped, then its volume V is equal to box of modulus of AB bar, AC bar, AD bar cubic units. And if A, B, C, D vertices of a tetrahedron, then its volume V is equal to 1/6 times mod of box AB bar, AC bar, AD bar cubic units. Vector triple product. A bar, B bar, C bar, 3 vectors. Then A bar cross B bar cross C bar and A bar cross B bar cross C bar are called, these two are called vector triple products. clearly noticed A cross B is a vector C bar between two vectors, and here A cross B cross C, it is a vector triple product. Vector triple product is a vector quantity, first property. VTP, you may call it vector triple product, VTP is a vector quantity. Scalar triple product is a scalar quantity, vector triple product is a vector quantity. And A bar cross B bar cross C bar is not equal to A cross B cross C. A relation between cross and the dot, that is A bar cross B bar cross C bar, right open, take the dot product with the left, that is A bar dot C bar into B bar, right open, take from the left A bar dot C bar into B bar minus B bar dot C bar into A bar. If left open, take from the right, that is A bar cross B bar cross C bar is equal to left open, that is C bar dot A bar into B bar minus B bar dot A bar into C bar. A cross B cross C equal to, right open, take from the left A dot C into B bar minus B dot C into A bar. A cross B cross C, left open, take from the right C bar dot A bar into B bar minus B bar dot A bar into C bar. This is vector triple product and its properties. Skew lines. What is skew lines? Skew lines concept. Skew lines ante enti? In the rectangular Cartesian system, you take coordinate axis, x axis and y axis. Rectangular Cartesian system lo, if you are going to take the lines may be parallel or the lines may be intersect in the rectangular Cartesian system. Skew lines ante lines, two lines are said to be skew lines if there does not exist any plane containing these two lines, they are called skew lines. Lines, two lines are said to be skew lines, two lines are said to be skew lines, if there does not exist any plane containing these two lines, called skew lines. Two lines are said to be skew lines if there does not exist any plane containing these lines, they are called skew lines. And skew lines will be neither parallel nor intersecting lines. If you take a line in the first plane, a line in the second plane, then they definitely does not intersect. That lines we called as the skew lines. There does not exist any plane containing these two lines, they are called skew lines. If L1 is equal to 0 and L2 is equal to 0, two skew lines. Consider L1 is equal to 0, vector equation of the line, L2 is equal to 0, another skew line, L1 equal to 0, L2 equal to 0, two skew lines. There exists a point P on L1, there exists a point Q on L2, that PQ, joining PQ will be perpendicular to both L1 and L2, then this length PQ is called shortest distance between L1 and L2. In your applications, find the shortest distance between the skew lines, we have got a problems. How to get the shortest distance between? Take the equation of the line passing through A bar and parallel to B bar, first skew line. Take the equation of the line passing through B bar and parallel to C bar and parallel to D bar. You take the first skew line, equation of the line passing through A bar parallel to B bar. So that L1 is equal to 0 is R bar is equal to A bar plus TB bar. First is Q line. L2 is equal to 0 will be R bar is equal to C bar plus SD bar. I took two skew lines, A bar plus TB bar, C bar plus SD bar. Then this PQ is nothing but projection of AC bar onto PQ bar, and we concluded that this PQ will be perpendicular to both first vector and second vector. So B bar cross D bar is B bar is parallel to first skew line, D bar is parallel to second skew line. So B cross D is perpendicular to both L1 equal to 0 and L2 equal to 0. So the shortest distance is nothing but projection of AC bar onto PQ bar. That is calculated by the formula. Shortest distance between the skew lines will be magnitude of box of A bar minus C bar, B bar, D bar divided by mod of B bar cross D bar units. The shortest distance between the skew lines, which are passing through A bar parallel to B bar, passing through C bar and parallel to D bar. Take the skew line concept and shortest distance between the skew lines. Definitely, which will be useful in the 3D as well as the vectors. In the last concept, angle between a line and the plane. Earlier classes we have seen angle between two lines. Angle between two lines, that is theta. L1 is equal to 0 and L2 is equal to 0. Angle between the two lines. Next classes we have seen angle between the two planes, that is pi 1 is equal to 0 one plane, pi 2 is equal to 0 is the second plane, pi 1 pi 2. Angle between two planes is nothing but angle between their normal vectors n1 bar, n2 bar. Angle between the two lines and angle between the two planes. Now how to get angle between a line and the plane? L is equal to 0, be a line, that is R bar is equal to A bar plus TB bar, passing through A bar parallel to B bar. Pi is equal to 0, be a plane, R bar dot N bar is equal to P. Now I wanted to find angle between a line and the plane. So pi is equal to 0, be a plane, and having N bar, and this is the angle. This is the line, L is equal to 0 and pi equal to 0, and this is N bar. So angle between a line and the plane is nothing but complementary angle between normal of the plane and the line. If theta is the angle between normal and the line, 90 minus theta will be the angle between line and the plane. So angle between line and the normal will be cos theta is equal to passing through A bar parallel to B bar, that B bar dot N bar divided by mod of B bar into mod of N bar, acute tuque modulus. Then angle between the line and the plane will be cos of 90 minus theta, B bar dot N bar divided by mod of B bar into mod of N bar, where cos 90 minus theta is equal to sin theta. Sin theta is mod of B bar dot N bar divided by mod of B bar into mod of N bar. This is the formula to calculate angle between a line and the plane, between the two lines, between the two planes, and line and the plane. ఇప్పుడు reciprocal vectors మా, the last concept. Reciprocal vectors అంటే ఏంటి? A bar, B bar, C bar, A bar, B bar, C bar, three non-coplanar vectors. A bar, B bar, C bar, three non-coplanar vectors. Then A dash bar is equal to B bar cross C bar divided by box ABC. B dash bar is equal to C bar cross A bar divided by box ABC. C C bar dash is equal to A bar cross B bar divided by box ABC. Then these A dash bar, B dash bar, C dash bar vectors are called reciprocal vectors of A bar, B bar and C bar. Take the definition of the reciprocal vectors. Triple product paina general ga elanti problems istadante, if box of ABC is equal to 3, box of A bar, B bar, C bar is equal to 3, then find volume of the parallelopiped with edges 2A bar plus B bar, 2B bar plus C bar and 2C bar plus A bar. Box of ABC is equal to 3. Then find the volume of the parallelopiped with edges 2A bar plus B bar, 2B bar plus C bar, 2C bar plus A bar. Now let the edges be P bar is equal to 2A bar plus B bar, Q bar is equal to 2B bar plus C bar, R bar is equal to 2C bar plus A bar. So volume of the parallelopiped V is equal to modulus of box of P bar, Q bar, R bar. But how P bar, Q bar, R bar? They are in the linear combination. So box of P bar, Q bar, R bar will be is equal to determinant of 3 by 3 matrix 2, 1, 0, 0, 2, 1, 1, 0, 2 into box ABC. The value of box ABC is given 3. On product we noticed that it is 2 times of 4 minus 0 minus 1 times of 0 minus 1 plus 0 times of anything will be 0 into box ABC is given as 3. So which is equal to 8 plus 1 into 3 which is 27 times of cubic units. The volume of the parallelopiped will be 27 cubic units. A bar, B bar, C bar, any 3 vectors. Box of A bar cross B bar, B bar cross C bar, C bar cross A bar is equal to box of A bar, B bar, C bar to the power of k. Then what is the value of k? A bar, B bar, C bar are any 3 vectors. Box of A cross B, B cross C, C cross A equal to box ABC to the power of k. Then the value of k is, now take the box of A bar cross B bar, B bar cross C bar, C bar cross A bar. Expanding by using scalar triple product, that is A bar cross B bar and a dot B bar cross C bar cross C bar cross A bar. Earlier just now we have discussed dot product of 3 vectors, but here we got 4 vectors. Whenever cross product of 4 vectors, you convert into 3 vectors. Let C bar cross A bar is equal to some R bar. Then the above value will be A bar cross B bar dot B bar cross C bar cross R bar, which is nothing but A bar cross B bar dot right open expand from the left B bar dot R bar into C bar minus C bar dot R bar into B bar. Replace the value of R bar by C bar cross A bar, which is nothing but A bar cross B bar dot B bar dot, it is C bar cross A bar times of C bar minus C bar dot C bar cross A bar times of B bar. This is nothing but A bar cross B bar dot C bar because anyhow it is a scalar, times of B bar dot C bar cross A bar, and this is C dot C, box CCA will be 0. So this is nothing but box of ABC. As two vectors we have rotated, this will become box ABC. Box ABC into box ABC is equal to box of A bar, B bar, C bar whole square. Therefore, K is equal to 2. A bar, B bar, C bar, any three vectors. Then what is the value of box of A bar cross B bar cross C bar, B bar cross C bar cross A bar, C bar cross A bar cross B bar. A bar, B bar, C bar, three vectors. Then the value of A cross B cross C, B cross C cross A, C cross A cross B is equal to how much? So, in order to calculate this box, I wanted to take these vectors in a combination. Let P bar is equal to A bar cross B bar cross C bar. Q bar is equal to B bar cross C bar cross A bar. R bar is equal to C bar cross A bar cross B bar. Consider P bar plus Q bar plus R bar, that is A bar cross B bar cross C bar plus B bar cross C bar cross A bar plus C bar cross A bar cross B bar. Expand using vector triple product. As it is left open, take the dot product from the right side. C bar dot A bar into B bar minus B bar dot A bar into C bar plus A bar dot B bar into C bar minus C bar dot B bar into A bar plus left open B bar dot C bar into A bar minus C bar dot A bar into B bar. And clearly notice that C dot A into B, C dot A into B with plus symbol minus symbol cancel. B dot A into C, A dot B into C, dot product follows the commutative law. These two will be 0 and we got 0 bar. What is the indication of this one? P bar can be written as minus 1 times of Q bar minus 1 times of R bar. Therefore, P bar, Q bar, R bar are coplanar. When the vectors are coplanar, their box value, box of P bar, Q bar, R bar will be is equal to 0. R bar be a vector perpendicular to A bar plus B bar plus C bar. If R bar is equal to L times of B cross C plus M times of C cross A plus N times of A cross B, then the value of L plus M plus N. I will repeat the question. R bar be a vector perpendicular to A bar plus B bar plus C bar. R bar is perpendicular to A bar plus B bar plus C bar, and that implies R bar dot A bar plus B bar plus C bar is equal to 0, because the vector R bar is perpendicular to A bar plus B bar plus C bar, and R bar is equal to L times of B bar cross C bar, M times of C bar cross A bar plus N times of A bar cross B bar. Then what is the value of L plus M plus N? R bar is the combination of B cross C, C cross A cross B with the help of the scalars L M N, the sum of the L plus M plus N, provided R bar is perpendicular to A bar plus B bar plus C bar. Now, in order to calculate first A bar, L value for the above vector, taking apply dot A bar both sides to the above relation. then r bar dot a bar is equal to a bar dot L times of b bar cross c bar plus m times of c bar cross a bar plus n times of a bar cross b bar. That is nothing but r bar dot a bar is equal to L times of this is a dot b cross c, box ABC, plus this is 0 and this 0, because box of CAC 0, box of AAB 0. And r bar dot a bar is equal to L times of box of ABC. Similarly, apply dot b bar, apply dot c bar. Then we can say that r bar dot b bar is equal to L times of box ABC and r bar dot c bar is equal to n times of box ABC. On adding both sides, r bar dot a bar plus r bar dot b bar plus r bar dot c bar is equal to, as I took a bar, b bar, c bar box common, it will be L plus m plus n. But in the above relation we noticed that this is 0 because r bar is perpendicular to a bar plus b bar plus c bar into L plus m plus n. As in the question mentioned that ABC are non-coplanar, box ABC, box of ABC not equal to 0, therefore L plus m plus n is equal to 0 because a bar, b bar, c bar non-coplanar. Let b bar is equal to a vector b bar is equal to 2i bar plus j bar minus k bar, and w bar is equal to I bar plus 3k bar. U bar is a unit vector. U bar is a unit vector. Then what is the maximum of box UVW? Maximum of box of U bar, V bar, W bar is equal to how much? V bar is equal to 2i bar plus j bar minus k bar, W bar is equal to I bar plus 3k bar, U bar is a unit vector. Then what is the maximum of box of UVW? And given that mod of U bar is equal to 1. Now you are supposed to calculate U dot VW box. Box of U bar, V bar, W bar is equal to U bar dot V bar cross W bar. First we calculate the value of V bar cross W bar. The value of V bar cross W bar is equal to determinant of 3 by 3 matrix I bar, J bar, K bar, and V bar. V bar is nothing but 2, 1, minus 1. W bar is 1, 0, 3. On expansion it is I bar times of 3 minus 0 minus J bar times of 6 plus 1 plus K bar times of 0 minus 1. That is 3 times of I bar minus 7 times of J bar minus K bar. Mod of V bar cross W bar is equal to square root of 9 plus 49 plus 1, that is root of 59. Put aside. Okay. Now we want to find box of U bar, V bar, W bar is equal to U bar dot V bar cross W bar, that is magnitude of U bar, magnitude of V bar cross W bar, and cos of angle between U bar, V bar cross W bar. This is 1 given in the problem and this is root 59, and if you take this angle will be given cos theta. So it is root 59 times of cos theta. In the trigonometry we learned that maximum of cos theta will be plus 1, minimum of cos theta will be minus 1. Therefore, maximum of box of U bar, V bar, W bar is equal to root 59. A bar, B bar, non-zero vectors, non-collinear vectors. A bar and B bar. non-zero and non-collinear vectors. Okay, then find the value of box of A bar, B bar, I bar plus A bar, B bar, J bar plus box of A bar, B bar, K bar in terms of A bar cross B bar. Find the value of box of A bar, B bar, I bar plus A bar, B bar, J bar plus A bar, B bar, K bar in terms of A cross B in a cyclic order. Provided how these A bar, B bar, they are non-zero, non-collinear vectors. So let A bar is equal to A1 I bar plus A2 J bar plus A3 K bar. B bar is equal to B1 I bar plus B2 J bar plus B3 K bar. What are A1, A2, A3? They are the direction ratios of A bar vector. B1, B2, B3 are the direction ratios of B bar vector. Now first we calculate A bar cross B bar because the resultant answer expressed in terms of A cross B. A cross B is equal to I bar, J bar, K bar, A1, A2, A3, B1, B2, B3 expanded. That is I bar times of A2, B3 minus A3, B2 minus J bar times of A1, B3 minus A3, B1 plus K bar times of A1, B2 minus A2, B1. The value of A cross B put aside. Express that box, 3 boxes value in terms of A cross B. And these are in the cyclic order it is given. First calculate box of A bar, B bar, I bar. That is equal to determinant of A1, A2, A3. B bar will be B1, B2, B3 and 1, 0, 0, which is nothing but A1 times of 0 minus 0 minus A2 times of 0 minus B3 plus A3 times of 0 minus B2, that is nothing but A2 B3 minus A3 B2. This is the value of box AB I. So we want box of AB into I, J and K. And this value is nothing but A2 B3 minus A3 B2 times of I bar. And the first box value if you calculate, it is A2 B3 minus A3 B2 into I bar. Here I bar and here J bar and K bar. So the above expression value will be sigma of A2 B3 minus A3 B2 times of I bar. But A cross B, A bar cross B bar is also sigma A2 B3 minus A3 B2 times of I bar. So that one and this one will be same. Therefore, which is equal to A bar cross B bar. Students, మొత్తం మనము వెక్టర్ ఆల్జీబ్రా టాపిక్స్ను ఒక 4 భాగాలుగా విభజించుకున్నాం. మొట్టమొదటి వెబ్సైట్లో ప్రాపర్టీస్ ఆఫ్ ది వెక్టర్స్, వాటి ధర్మాలు, డెఫినేషన్స్, ఫార్ములాస్ డిరైవ్ చేసుకున్నామా. ఇచ్చినటువంటి లెక్కలో ఎటువంటి ధర్మాన్ని, ఎటువంటి సూత్రాన్ని ఏ విధంగా అప్లై చేయాలనేది క్రిస్టల్ క్లియర్గా కొన్ని ఎగ్జాంపుల్స్ ద్వారా ఎక్స్ప్లెయిన్ చేసాం మనం. రెండో భాగంలో ఈక్వేషన్ ఆఫ్ ది లైన్, ఈక్వేషన్ ఆఫ్ ది ప్లేన్, యాంగిల్ బిట్వీన్ ద ప్లేన్స్, లైన్ అండ్ ద ప్లేన్, వాటికి సంబంధించిన విషయములు, పాయింట్ ఆఫ్ ఇంటర్సెక్షన్ ఆఫ్ లైన్స్, పాయింట్ ఆఫ్ ఇంటర్సెక్షన్ ఆఫ్ ప్లేన్స్, పాయింట్ ఆఫ్ ఇంటర్సెక్షన్ ఆఫ్ లైన్ అండ్ ద ప్లేన్ ఏ విధంగా క్యాలిక్యులేట్ చేయాలి, వాటి విషయాల గురించి మాట్లాడుకున్నాం. దాని ద్వారా కొన్ని ఎగ్జాంపుల్స్ కూడా చేయగలిగాం. మూడో విభాగంలో ప్రోడక్ట్ ఆఫ్ ది వెక్టార్స్, ప్రోడక్ట్ ఆఫ్ ది వెక్టార్స్లో డాట్ ప్రోడక్ట్, క్రాస్ ప్రోడక్ట్, డెఫినేషన్ ఆఫ్ ది డాట్ ప్రోడక్ట్, ప్రాపర్టీస్ ఆఫ్ ది డాట్ ప్రోడక్ట్, డెఫినేషన్ ఆఫ్ ది క్రాస్ ప్రోడక్ట్, ప్రాపర్టీస్ ఆఫ్ ది క్రాస్ వాటిపైన సూత్రాలు, ధర్మాలు, తర్వాత వాటి మీద కొన్ని లెక్కలు, వీలైనంతగా సాధించగలిగాము. మళ్ళీ లాస్ట్ కాన్సెప్ట్లో ద ఫోర్త్ పార్ట్ ఆఫ్ ది వెక్టర్ ఆల్జీబ్రాలో ట్రిపుల్ ప్రోడక్ట్స్, స్కేలార్ ట్రిపుల్ ప్రోడక్ట్, వెక్టార్ ట్రిపుల్ ప్రోడక్ట్, స్క్యూ లైన్స్. తర్వాత ఈ స్క్యూ లైన్స్ని ఏ విధంగా ఉపయోగించుకొని వాటి మధ్యలో షార్టెస్ట్ డిస్టెన్స్ క్యాలిక్యులేట్ చేసే ఫార్ములా కానీ డెరైవ్ చేసుకున్నాం. అయితే కాంపిటేటివ్ ఎగ్జామినేషన్లో మీరు గుర్తుంచుకోవాల్సిన విషయము, ఒక కాన్సెప్ట్కు సంబంధించిన ప్రశ్నలు ఎటువంటివి ఇవ్వరు. కనుక ఫస్ట్ యూ రీడ్ అవుట్ ద క్వశ్చన్ అండ్ ట్రై టు అనలైజ్ ద క్వశ్చన్ పార్ట్, కాన్సెప్ట్ పార్ట్, అప్లికేషన్ పార్ట్ అండ్ ద క్యాలిక్యులేషన్ పార్ట్. So 50% of the student, they will unable to understand what is the given question. You may take physics or mathematics or any concept, vectors or calculus. First part you try to read the question, analyze the question. In the question itself 50% of the solution will be noticed. Okay, దాని తర్వాత what the concept we have learned, explain it and submit. Calculation part is also very important. So ఈ మూడు భాగాలను బాగా చూసుకుంటే మీరు ప్రతి ఒక్క కాంపిటేటివ్ ఎగ్జామినేషన్లో సక్సెస్ కాగలరు. మనము కాంపిటేటివ్ ఎగ్జామినేషన్కి వెళ్ళినప్పుడు ఎగ్జామినేషన్ హాల్కు మొట్టమొదట ఒక హాఫ్ అన్ అవర్ ముందుగా రీచ్ అయ్యే విధంగా చూసుకోండమ్మా. ఎందుకంటే ప్రిపరేషన్ ఈజ్ డిఫరెంట్, రైటింగ్ ఎగ్జామినేషన్ ఈజ్ డిఫరెంట్. ఎగ్జామ్ హాల్లో ప్రశాంత వాతావరణంలో ఎగ్జామ్ రాశారనుకోండి, దానికి అలజడితోటి, అంటే లాస్ట్ మూమెంట్లో ఎగ్జామినేషన్ హాల్కు అటెండ్ కావడము, టైము ఆ సమయాభావాన్ని పాటించకుండా వెళ్ళినప్పుడు మీరు 2 సంవత్సరాలు కష్టపడి కాంపిటేటివ్ ఎగ్జామినేషన్లో కూర్చున్నప్పుడు ఏమాత్రం సాధించలేరు. రెండో విషయం, ఎగ్జామినేషన్ హాల్ ముందు రోజు ఎటువంటి హడావిడి కాకుండా ద కాన్సెప్ట్ ఆర్ విచ్ సబ్జెక్ట్ యూ డిడ్ నాట్ లర్న్. ఫర్ ఎగ్జాంపుల్ మ్యాథమెటిక్స్లో ఒక టాపిక్ మీరు నేర్చుకోలేదనుకోండి, ఆ టాపిక్ను పక్కన పెట్టండి. దానివల్ల ఏమవుతుంది, వెన్ యూ హ్యావ్ డిసైడెడ్ దాట్ యువర్ మైండ్ ఈజ్ ట్యూన్ దట్ యూ హ్యావ్ నాట్ ప్రిపేర్ దట్ కాన్సెప్ట్, దెన్ రెస్ట్ ఆఫ్ ది క్వశ్చన్స్ యూ అటెంప్ట్ ప్రాపర్లీ. ఆ విషయాన్ని బాగా గుర్తుంచుకోండి. జనరల్గా స్టూడెంట్ మెంటాలిటీ ఎలా ఉంటుందంటే, ఇఫ్ ఈజ్ నాట్ కాన్ఫిడెంట్ ఆఫ్ ది 23rd క్వశ్చన్, దెన్ ఇట్ ఈస్ ఎఫెక్టెడ్ 24th క్వశ్చన్ అండ్ 25th క్వశ్చన్ ఆల్సో. When your mind is tuned that I am not able to solve the 23rd question, then definitely rest of the questions will be solved. కనుక నేను చెప్పేది ఏంటంటే, ఎగ్జామినేషన్ హాల్లో నీ ప్రవర్తనావళి దట్ ఈస్ మెయిన్ రోల్. నువ్వు ఎంతకాలం రాత్రి మొత్తం ప్రిపేర్ అయింది అది కాకుండా ఎగ్జామినేషన్ రాసే వ్యవస్థను కూడా కాస్త అర్థం చేసుకొని ప్రాక్టీస్ టెస్టులు రాయడం ద్వారా ఈజీగా మీరు కాంపిటీషన్ ఎగ్జామ్ను సాధించగలుగుతారు. ఓకే.